Hey y'all. Today's objective is transforming functions. So we've been working with functions and now we're going to transform them. So here's some vocabulary. A transformation is the change in the position of a graph. You might remember doing some transformations earlier. Translation is a horizontal or a vertical shift. Other words, a slide. So it's going to shift vertically, horizontally, or sometimes both. We're going to use the letter H for horizontal and K for vertical. I don't know why it's a V, if that's what you're wondering, but the letters most commonly used are H and K. H for horizontal, K for vertical. Your parent function is your original function, so like your f of x. We've talked about function notation. So your original function is called your parent function. And then your family functions are your transformed functions. So you have a parent function, then when you transform that function, you're going to have children, family functions. All right, so make sure you get all this down and I'm going to explain. Vertical translations with the K. F of x is your parent function, and then if you want to translate it vertically, you're going to add a K on the outside. That's your child function. If K is positive, that means you're going to slide it up. If K is negative, that means you're going to slide it down. And the way you'll know it's negative is it's going to have a minus right there. So here's an example. If you had a function, f of x is x plus 2. That plus 2 means it's going to be shifted up. If you have x minus 2, that means it's going to be shifted down. So that's a vertical translation. A horizontal translation, denoted by H, is going to be inside the parentheses. Notice, outside, inside. You have f of x as your parent function, and you put an H plus H inside, that's going to be your child function. A positive H, you may think is going to go right, but in actuality it's opposite inside the parentheses. Positive H is going to go left, and a negative H is going to go right. So what that means, if you have an example like this, x plus 2 inside parentheses, this is really going to shift 2 units left. And if you have an x minus 2 inside parentheses, this is really going to shift 2 units right. So we're going to use some right examples. We're going to write equations for examples. So the first one is if you have a parent function, you want to shift it 8 units down. So if you're going down, it's going to be minus k. So f of x is your parent function minus 8. So that's your equation, f of x minus 8. If you want to do 6 units left, remember it's opposite when you're going left and right. So that's really going to be a plus 6 inside parentheses. Outside parentheses is vertical, inside parentheses is horizontal. So you're going to do f of x plus 6. 2 units up is going to be f of x plus 2. 5 units right. In order to go right, it's going to be the opposite. So it's going to be minus 5. And because it's horizontal, it's going to go inside the parentheses. So f of x minus 5. That means it shifts this parent function 5 units to the right. Now number 5, we have a combo. 3 right and 4 down. So 4 down I know is going to be minus 4. 3 right is going to be minus 3 because right means you're going to have to go the other way, or negative. So to do a combo, first we have to do the right inside the parentheses, like this one, and then on the outside we do our minus 4. That's how you do a combo. Number 6, 7 up is going to be plus 7, 1 left is going to be plus 1. This one goes inside, left, right will go inside the parentheses, and the plus 7 will go on the outside. So don't get confused and don't put plus 7 inside just because it comes first. You have to pay attention to the direction. Alright, so here are some examples of graphing. I have a coordinate plane, and this black line right here is the parent function, f of x. So I showed you, I wanted to translate it, f of x plus 1, which means we're going to go up 1. The red one, I've shown you, I took all the dots and I just went up 1 unit. So I've shifted it up 1 unit. Number 2, f of x plus 3. So that means since it's plus 3, you're going to go 3 left. So the blue one from the parent function, not from the red one, but from the original parent function. So I'll go back to the parent function, and I went 3 spaces left. 1, 2, 3, 1, 2, 3, 1, 2, whoops, 1, 2, 3, and 1, 2, 3. So the blue one is number 2. Now this last one, f of x minus 2. The minus 2 means 2 down. So I'm going to go to my parent function, and I'm going to take these points, and I'm going to go 2 units down. 1, 2. 1, 2. 1, 2. 1, 2. And then I'm going to connect, and so that is number 3, how you graph a transformation based on the equation. So there's a special type of function called an absolute value function. Absolute value function. If you remember, absolute value is when you have the number inside the bars, and basically it's the distance away from 0. So it's never going to be negative inside the absolute value. We denote it with y equals the absolute value of x, or y equals the opposite absolute value. So sometimes you'll have a negative on the outside. The graph is a V-shaped, either upward or downward. If it's like this, the V is going to go upward. If it's like this, the V shape is going to go downward. So upward, downward. Let's practice writing some equations for absolute value. Y equals absolute value of x. So if we want to shift it 2 units up, that means we do a plus 2 on the outside. Plus 2 on the outside. We want to shift it 3 units left. That's going to go on the inside, and because it's left, we actually need to add 3. So in this part, you use your absolute value bars kind of like your parentheses. Down 4, right 3. So down 4 I know is going to be minus 4. Right 3 is going to be minus 3. The down goes on the outside of the bars, and the right goes on the inside. So left 5 would be plus 5, and up 1 would be plus 1. The up 1 has to go on the outside of the parenthesis, or the absolute value bars, because the vertical translation is on the outside. 7 right would mean minus 7. So there we go. Writing equations, writing an absolute value equation based on the translation. So our last few examples, I'm going to show you how to write an equation from the graph. This one right here is y equals absolute value of x, parent function. This black one down here is y equals negative absolute value of x, the opposite, so it's going downward. So the number one, this blue one, from the original parent function, it has gone 1, 2, 3 units up. So to write that equation, we would do plus 3 on the outside because it's gone 3 units up. That's it. That's how you write the equation. The second one, and I don't have a green marker, the second one has actually had a combination of shifts. It's gone 1, 2, so it's gone this way, 2, which would be right 2, and it's gone down 1. So when we put that into, and it's going downward. This absolute value function is going down. So when we do this equation, we have to do the negative. We went right 2, so that would be minus 2, and then we went down 1. So that is the equation that matches this green graph.